right, for number 21, let's see, they give me BE is congruent to CE. Then they give me AE is congruent to DE. All right, so I could prove the triangles are congruent by what? All right, well, what other information can I extract just by looking at this diagram? Well, I know that these are vertical angles here. Right? So I can say that triangle, let's see, we have ABE is congruent to DCE. All right, the order of the letters matters. All right, by what shortcut? SAS. Done. All right, gonna have to write out a proof here. Got my statement, then my reason. All right, first I'm going to state what they gave me. PK is parallel to QN, and PN bisects KQ. Okay, and both of those were given. All right, let's label the diagram with that information. PK is parallel to QN. All right, and PN bisects KQ. PN bisects KQ. KQ is bisected. All right, so I have to state that KM is congruent to MQ. All right, and how do I know that? That's just definition of segment bisector. All right. All right, let's see. For what else do I have to work with now? I could say that these angles are congruent. So I could say that angle PMK is congruent to angle NMQ. Okay, and those are vertical angles. All right, then I could say P is congruent to N. All right, and those are alternate interior angles. All right, they told you that the sides are parallel for a reason. All right, now I could say that the triangles are congruent. Let's see, PMK, triangle PMK is congruent to triangle NMQ. Okay. And the reason is AAS. Okay, now I can say that these sides here are congruent. All right, I could say that PM is congruent to MN. And that's by CPCTC. Corresponding parts of congruent triangles are congruent. Then I can get to what I've been wanting to prove all along. KQ bisects PN. Well, how do you know that? Well, I know that those two segments are congruent, so that's just definition of segment bisector. All right, done. All right, next problem. PR bisects both angle SPQ and QRS. Okay, bisects SPQ, so I know those are the same. And it also bisects QRS, so I know these are the same. All right, let's see. I think I'll write out my columns here. Got my statement and the reason. Okay. So for one, I have PR bisects both angle SPQ and angle QRS. All right, and that's just given. Then I can say angle QPR is congruent to angle SPR. That's just definition of angle bisector. All right, and 3, I could say angle QRP is congruent to angle SRP. And that's also by definition of angle bisector. All right. And I know they both share this side in common. So PR is congruent to PR. That's by the reflexive property. And then I have triangle PQR is congruent to triangle PSR by what shortcut? Angle, side, angle, right? Angle, side, angle. Done. All right. Set up my 2 columns here. Statement, reason. Okay, so for 1, we have AX is parallel to BY, and AY is parallel to BZ, and Y is the midpoint of XZ. Okay, and that's given. All right, 2. Let's label the diagram first. I have AX is parallel to BY, and I have AY is parallel to BZ. Okay, and Y is the midpoint of XZ. So I know those are congruent. All right, so I'm going to say XY is congruent to YZ. That's by definition of midpoint. Okay, then I can say what else? Well, you want to use this information every time. They give it to you for a reason. All right, so I have these 2 lines, and then I have that transversal. So these are congruent. Those are corresponding angles. So angle X is congruent to angle BYZ. And those are corresponding angles, okay? And then I have these 2 lines here that are parallel, and I have this transversal. So I have these 2 angles here. All right, so I have angle Z is congruent to angle AYX. All right, and the reason? Those are corresponding angles. Okay. Now I know the triangles are congruent by what shortcut? Angle, side, angle. All right. Done. All right, 25. Okay, there's the diagram that was missing. All right, so I have X. Well, let me write out my, oops. Let me write out my statement and reason. All right, so 1, I have angle X is congruent to angle Z. Then I have angle A is congruent to angle B. And I have Y is the midpoint of XZ. And that's given. All right, so I have angle X is congruent to angle Z. And I have angle A is congruent to angle B. And I have Y is the midpoint of XZ. So here, these are the same. Okay, so then I have 2. All right, what can I extract? Okay, I could say X, Y is congruent to YZ. That's just by definition a midpoint. All right, now I'm trying to prove AXY is congruent to BZY. Well, I could do that now. That's easy. All right, so triangle AXY is congruent to triangle BZY. By what reason? What shortcut can you apply? AS. That's all there is to this proof. We're done. All right, they already set the columns up for me. That's pretty nice here. All right, PR bisects SPQ. Okay. All right, so we have all the given information here. PR bisects angle SPQ. And we also have angle Q and angle S are right angles. That's all given information. All right, then I know QPR is congruent to SPR. Why? Well, the angle is bisected. So that's just definition of angle bisector. All right, then it says right angles are congruent. Well, I know angle Q is congruent to angle S. They told me in the beginning that the angles are right angles, and so right angles are congruent. Then we have the reflexive property. So PR is congruent to PR. That should be more squiggly. All right, and I could say the triangles are congruent by what shortcut? AS. AS. Alrighty, done. Okay, here they tell me angle 2 is congruent to angle 8. That's given. Alright. Angle 2 is congruent to angle 8. Then they tell me angle 2 is congruent to angle 4 and angle 6 is congruent to angle 8. Those are vertical angles. Then it tells me 4 is congruent to 6. How do you know that? Okay, well, that's transitive property here. I wish they would have included just one more statement, because they used all 3 of these pieces of information at once, together. All right, so just to break it down for you, here I have 2 for both of these. So they said 4 is congruent to 8. Okay, now that 4 is congruent to 8, here I have 8 for both of these. So then I know 4 is congruent to 6, and that's where this comes from. All right, and that's transitive property. And then now I could say that these lines are parallel. By what reason? Well, these are alternate interior angles here. Okay, but whenever you're providing a reason for why lines are parallel, you use the converse. All right, whenever you're trying to prove lines are parallel. All right, that's all there is to that. All right, explain the difference between XY, the quantity, and XY, the segment. All right, XY describes a length And this XY, with the segment symbol above it, describes a shape. All right, so for example, if you say XY, then you're going to set it equal to a number. For example, 4. This is just an example. All right, if you're going to say XY, then you're not talking about a number, you're talking about a picture. You're looking at some picture, the segment XY. Okay? Twin, explain the difference between this notation. All right, measurement of angle PQR describes an angle measurement and angle PQR describes a shape. So let me give you a concrete example. Measurement angle PQR, whenever you see something stated like this, you would set it equal to a numerical value, for example, like 35 degrees. All right. And then here's another example. If you see this type of notation, angle PQR, all right, then that is referring to a picture. PQR. Okay. So one has to do with the numerical quantity, and the other has to do with a shape, a visual reference. All right, give all the possible names of segments shown in the diagram. Okay, I could say segment AB. I could also call it BA. I could say segment BC. I could also call it CB. And I have segment AC, which I could also call CA. Alrighty, done. All right, give all the possible names of segments shown in the diagram. Same thing as before, PQ or QP. Then I have QR or RQ. And then I have PR or RP. Done. All right, find X so that L is parallel to M. All right, so if I want to show that these are parallel, then I must set these equal to each other because those are corresponding angles. So 3x minus 12 equals 42. Add 12. I have 3x equals 54. Divide by 3. And x is equal to 18. Done. All right, find x so that L is parallel to M. Okay, well, what's the relationship between these angles here? There's no name for this pair of angles, and if that's the case, then they're supplementary. So I say 7x minus 1 plus 3x plus 11 equals 180. Alrighty, and I'm going to add like terms. Subtract 10 here. 10x equals 170. Divide by 10. X is equal to 17. Done. All right, determine whether each of the following statements is true or false. In the drawing, C, Z, and A are coplanar. Okay, this is sometimes a little difficult to understand just looking at a diagram. Sometimes you need like a three-dimensional representation. All right, but you don't want to just go by what you see in the diagram. Imagine passing a piece of paper, a plane, through these 3 points in space. So you have C here, you have Z here, and you have A here. So I could take a piece of paper, and I could just run it through all these points diagonally. All right. If it's difficult for you to see that, let me know, and I'll provide you with a physical representation of actually what's happening here. All right. And one thing to be aware of is you don't want to just go by the diagram. You need to understand that through any 3 points, you could pass a plane through them. Okay, it doesn't matter where 3 points are located in space. Well, this is two-dimensional since you're looking at a screen, but it doesn't matter where you place 3 points in space. You can always run a plane through them. Or you could look at it like this too if you want. All right. All right, so your answer is true here. In the drawing, B, C, D, and X are coplanar. Okay, in the previous example, we worked with 3 points. In this problem, we're working with 4. Okay, so 4 points are not always coplanar. Let's see what we have to work with here. We have B, we have B, we have C, we have D, and then we have X. Are they coplanar? Well, this plane runs through B, C, and D. All right, and it's going to keep going in this direction, in this direction, in this direction, and in this direction. It's never going to get up here to X. So your answer would be no. Or you could say false. Okay. All right, done. All right, 36. Name 2 straight angles shown in the diagram. So straight angle means that it's a 180-degree angle. The most obvious is this one right here for me. Angle DEF. Or you could also call it FED. I would say without a doubt that's fact right there because you know these are 90-degree angles. Or actually maybe that cannot be a 90-degree angle. Alright, I wish personally they were a little more precise with the information in this diagram, but I guess you're sort of assuming based off of looks. So you could say that this is a straight angle here. Could also call it FGA. You could say that this is a straight angle here. You could use different points as well. Alright, so there's a bunch of different ones you could choose. Alrighty. Name 2 straight angles shown in the diagram. Alright, same deal here. There's a straight angle. Or you could call it ECF. Alright, then I have one right here. Alright, then I have angle ADF or angle FDA. Alright, you could go this way as well. There's a bunch of different ones, okay? Take your pick. Angle 1 and angle 2 are adjacent. Alright, so for this one I'm determining if the statement is true or false. Alright, in order to be adjacent, they have to share a side in common. Alright, I have these 2 angles here. And they share this side in common. So that's true. They're adjacent. Angle 1 and angle 2 are supplementary angles. Well, you don't know if this is a 90-degree angle, if that's 90 degrees. I mean, this could be 0.1 degrees off from being straight. But I guess they just want you to go by looks. So they're saying, yeah, it's true, because together they form a line. Alright, so you just want to assume that it's straight then. And for number 40, in the diagram, ray XA is perpendicular to ray XC. Alright, they're perpendicular, so that's a right angle there. Name a pair of complementary angles. All right, so then I definitely know that angle 1 and angle 2 are complementary. I could just as well say angle AXB and angle BXC are complementary. All right, done with that.